Hello guys, so right now I'll be explaining the past paper questions. In total there are 7 questions. So we have the IG Chemistry past paper questions. The first one is from June 2021, paper 62, question 2. These are all given by the school. Nothing is external, so we have to follow what the school gave us. So let's start. A student investigated the volume of gas made when sodium carbonate reacts with dilute hydrochloric acid. That means it's not very concentrated. That's the meaning of dilute. Now, 5 experiments were carried out using the apparatus shown. We have a rubber tube, a bung, which is the stopper, the boiling tube, a clamp, inverted 100 centimeter cube measuring cylinder, and a trowel and water. Experiment 1. Using a measuring cylinder of 16 centimeter cubed of dilute hydrochloric acid was poured into a boiling tube. The apparatus was set up as shown in the diagram. The bung was removed from the boiling tube. 2.5 grams of sodium carbonate was added to the boiling tube, and the bung was immediately replaced. When no more gas was being collected, the volume of the gas in the measuring cylinder was measured. Now, experiment 2. Experiment 1 was repeated using 14 centimeter cubed of dilute hydrochloric acid instead of 16 centimeter cubed. Experiment 2 was repeated with 12 centimeter instead of 14. Then for experiment 4, experiment 3 was repeated and using 10 instead of 12. And finally, for experiment 5, experiment 4 was repeated using 6 centimeter cubed instead of dilute hydrochloric acid instead of 10 centimeter cubed. So they're telling us, use the information in the description of the experiments and the inverted measuring cylinder diagrams to complete the table. So in experiment 1, they need the volume of hydrochloric acid per centimeter cubed used. So we're gonna go back up. We're gonna see in experiment 1 they used 16 centimeter cubed of hydrochloric acid. So the answer for the first one is 16. Now the volume collected of gas, we're gonna look here. If you see, it is approximately between. It's not 55 because this is 55, so we will say that it's 56 centimeter cubed. So the volume of gas collected was 56 centimeter cubed for experiment 1. For experiment 2, we're going to go up. They used 14 centimeter cubed of hydrochloric acid. So the volume in experiment 2 of hydrochloric acid was 14 centimeter cubed. Now, if we're going to measure it, it is approximately, oh my goodness, I can't draw. It is approximately 49 centimeter cubed. So 49 centimeter cubed of gas was collected. For experiment 3, they used 12 centimeter cubed. So we're going to go down again. How much was used of hydrochloric acid? It was 12 centimeter cubed. And how much was collected? I would say it's approximately 44 centimeter cubed. Now we go back to 4. In experiment 4, they used 10 centimeter cubed. So we're going to go down again. We're going to say here 10 centimeter cubed of hydrochloric acid was used. And approximately 37 centimeter cubed was collected of gas. Then finally, for experiment number 5, we used 6 centimeter cubed. So here we used 6 centimeter cubed of hydrochloric acid, and then we collected approximately 26 centimeter cubed of gas. Now, draw a suitable scale on the y-axis and plot the results. So part B, draw a suitable scale on the y-axis and plot the results from experiments 1 to 5 on the grid. Draw a straight line of best fit. So here is the volume of gas collected compared to the volume of dilute hydrochloric acid. Of course, in the exam you're gonna have this. You're gonna have them in front of you. So I wrote it on a paper. You guys can write it on a paper. So we have for 16 centimeter cubed of hydrochloric acid, we collected 56. So let me zoom out. I don't think I can, so I'll just do it like this. 16 was over here, so we collected 56. I would say approximately here. Okay, then we collected 14 and 414 we collected. So I think, let me go down again. All right, I don't know how to zoom out, so let me just flip my tablet. It will be better. There we go. Now, so now never mind, it's much better. So let's label it actually, so we don't get mistaken. So I think 4 is there. Then I will say that the maximum is 56. So what's the difference between 4 and 56? And so then, for example, it's not gonna be accurate. So I'm just gonna draw it. It's gonna be inaccurate for me, but who actually cares for now, as long as it's correct. So 44, 37, then 26, for example. Okay, so I know it's not accurate, but it's for the sake of explaining it. Okay? Now, at 16, we got 56, so 56 it is. Then at 14, we got 49, so I'm gonna say that 49 is over here. Then at 12, we got 44, so I'm gonna say that 44 is over here. Then at 10, we got 37, so if 37 is over here, we're gonna put the point over here. And then finally, at 6, so actually wait, let me put the 26 over here then. All right, at 6, we got 26, so we would draw it over here. And if you notice, if you connect all the dots, they form a straight line. So our graph is supposed to look something like this. The line is drawn as a straight line. Now for part C. From your graph, deduce the volume that would be collected if 7 centimeter cubed of dilute hydrochloric acid was used. So logically thinking, if we use 26, okay, let me do it again, 56. Okay, so this is something what our graph looked like. Let me now draw the slope. So now they're telling us we need to deduce the volume of gas that would be collected if 7 centimeter cubed of dilute hydrochloric acid was used. So 7 is over here. We're gonna draw, and we're gonna get that it is approximately 29. I would say 29 or 30. So shown clearly on our graph how we worked out our answer. We drew it here. So we got 30 or 29, whatever you would like to put. This is our answer for part CI. Now for part CII. The volume of gas per centimeter cubed of dilute hydrochloric acid can be calculated using the equation shown below. Volume of gas per centimeter cubed of acid is equal to volume of gas collected in centimeter cubed over volume of acid in centimeter cubed. So use the equation to answer to part CI. Calculate the volume of gas per centimeter cubed. So we know that in 7 centimeter cubed, we got 30 or 29 centimeter cubed. So if we're gonna replace it, we're gonna put 30 over 29, or not, sorry, 30, for example, let's say 30 centimeter cubed, then we're gonna divide it by the volume of acid in centimeter cubed, which is our hydrochloric acid, which is 7. So our answer is 30 over 7. Now part D, the bung, which is the stopper, was removed and then replaced immediately after the sodium carbonate was added to the boiling tube. Explain why the bung must be replaced immediately so we do not lose any gases. This is if you want to describe it in a brief way, or if you want to describe it in a more professional way, it is to prevent the escape of gases. Now that is DII. That's DI. Now DII. Explain how the apparatus could be altered so that the bung does not have to be removed. You may draw a diagram to explain your answer. Okay, so the point of removing the bung was to add the sodium carbonate so that we would start the reaction. So we need a substitution instead of removing the bung. What we could do is that we could use a divider or a divider for the flask, okay, to separate the two reactants. Okay. Now, to start this reaction, the only thing we would need to do is to shake the reaction. It's not for part E, this is all for part DII. Okay, to shake the reaction, okay, to start it. That was for part DII. Now for part E. State 1 advantage of using a burette rather than a measuring cylinder. Of course, we know that a burette is more accurate than a cylinder to measure the volume of the dilute hydrochloric acid. Now F. In experiments 1 to 5, the sodium carbonate was in excess. Sketch on the grid the graph you would expect if all of the experiments were repeated using dilute hydrochloric acid of half the concentration. Definitely, if we're going to use half of the concentration, then everything will probably half. The volume will for sure half. Okay. And as well, our graph or our slope will be under our original one. So that is for part F of the past paper 62 question 2. Now I will go to the next past paper. Okay, so these are the IGCSE papers of June 2020, paper 42, questions 3 till 4. Now, sulfuric acid is made from sulfur in a 4-stage process. First, sulfur is converted to sulfur dioxide, then sulfur dioxide is converted to sulfur trioxide, then sulfur trioxide is converted into oleum, and then oleum is converted into sulfuric acid. How is sulfur converted into sulfur dioxide in stage 1 with the... how is sulfur converted into sulfur dioxide? It reacts with oxygen, or you can say air, and then it's converted into sulfur dioxide. Describe how sulfur dioxide is converted into sulfur trioxide in stage 2. Your answer should include an equation for the reaction, the temperature used, the name of the catalyst used. So, the equation of the reaction is how is SO2 converted into sulfur trioxide? It is. Alright, so we're gonna write SO2 reacts in the presence of oxygen, so it burns to form sulfur trioxide. If we want to balance it here, it will be 1/2. Now, the temperature used is 450 degrees Celsius, and our catalyst is called vanadium 5, which is the oxide. So that is for part 2. Part 3. Stage 2. The reaction in stage 2 can reach equilibrium. What is meant by the term equilibrium? There's a difference between reaching equilibrium and recognizing equilibrium. So here they're asking us reaching equilibrium. The term equilibrium means that the forward and backward reactions are equal. Alright? There is a continuous dynamic microscopic process that is in opposite. There is actually 2 continuous dynamic microscopic processes that are in opposite directions, yet no visible changes or no changes in macroscopic properties. So let me explain this. Equilibrium is when the forward and backward reactions are equal, but at the same time there are two continuous dynamic microscopic processes that are happening in opposite directions, meaning that you have the forward reaction happening and the backward reaction happening at the same time. Okay, so these are microscopic changes, yet there are no macroscopic changes. Macroscopic properties are properties that can be measured or seen. Now part B, sulfur trioxide is converted into oleum, H2S2O7 in stage 3. What is sulfur trioxide reacted with to convert it into oleum? It is reacted with H2SO4. So please remember this. Now H2SO4 is sulfuric acid. Oleum is converted into sulfuric acid in stage 4. Write a chemical equation for the conversion of oleum H2S2O7 into sulfuric acid. So H2S2O7 will react with H2O to produce 2 sulfuric acid, which is H2SO4. Now, part D. When copper is reacted with hot concentrated sulfuric acid, sulfur dioxide gas is formed. Balance the equation for this reaction. So let us balance it here. Copper, we have 1. Hydrogen, we have 2. Sulfur, we have 1. And oxygen, we have 4. Here we have copper, 1. Then we have sulfur, 1. Oxygen, 2. Hydrogen is 2. And then 1. Now, right now I'm balancing it. You guys should know how to balance it. So here the hydrogen is 2, here the hydrogen is 2. We keep it. Here sulfur is 1, here sulfur is 1. We keep it. But here oxygen is 3 in total, and here oxygen is 4. So what happens if we multiply this by 2 is that this becomes 2 and this becomes 4, but now they're still not balanced. So what we're gonna do is that we're gonna multiply this one by 2, and now this becomes 4 and this becomes so basically to balance it, we can very simply put a 2 here and a 2 here, and it is balanced. And I did a mistake, I forgot the S here, so in total we have 2 S's. Anyways, by putting a 2 here and a 2 here, it is gonna be balanced. Now, sulfur dioxide is a reducing agent. Give the color change that occurs when the excess. Okay, so sulfur dioxide is a reducing agent, meaning that it will reduce the other reactants. So we have sulfur dioxide, acidified aqueous, potassium magnate. This color is purple. So whenever you have potassium magnate, it is a purple color. So our starting color is purple, and because sulfur dioxide is our final is like our reducing agent, it will reduce the color until there is no color, so we call it colorless. Now part F. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the chemical equation for this reaction. So sulfuric acid is H2SO4 plus ammonia, which is NH3. It will produce ammonium sulfate, which is NH4 2SO4. Now to balance it, it's gonna be a 2 over here. So H2SO4 plus 2NH3 gives us NH4 2SO4. You guys are supposed to know these, they're very important. So part G, barium sulfate is an insoluble solid. So it is an insoluble salt, but barium sulfate can be made from aqueous ammonium sulfate. Anything to do with ammonium is soluble. I think we took it this week using a precipitation reaction. So if we need to produce barium sulfate and we are using ammonium sulfate, how will we get rid of the ammonia? We know that the ammonia contains nitrogen. So to get rid of the nitrogen, we are going to be using barium nitrate. So let's think of it like this. Barium sulfate is Ba2+, okay? And sulfate is SO4 2-, and ammonium sulfate is NH3+, and sulfate is SO4 2 minus. And so we need to produce what? To produce barium sulfate. So definitely we are going to be adding something with barium to our reaction. And then, sorry, this over here is Ba2 plus, and then it can be anything over here. So they said barium nitrate, we can put NO3. Now because we have NH3 plus, anything, because we have NH3 plus, anything with NH3 plus will be soluble. So these two will be forming an aqueous solution, which is NH3 plus, NH3NO3, which is an aqueous solution, and then the Ba2 plus and SO4 2 minus will form BaS. So BaSO4 solid. It is a precipitate. So if we are going to write the ionic equation, it is going to be Ba2 plus SO4 2 minus will form Ba. These are both aqueous, don't forget, both of them are aqueous. They will form BaSO4 solid, a precipitate. Now, number 4. So, oxygen is produced by the decomposition of hydrogen peroxide. Manganese IV oxide is the catalyst for the reaction. What's meant by the term catalyst? Catalyst increases reaction rate by speeding up forward and backward reactions and providing a lower activation energy, all without being consumed. Now, for part B, a student measures the volume of oxygen produced at regular time intervals using the apparatus shown below. Now, what happens to the rate of this reaction as the time increases? As our time is increasing, we started with a sudden increase in the rate of the reaction, then over here it starts to slow down, and then finally it is finished. Why is it finished? Because our limiting, this is very important, not our reactants, our limiting reactant was used up. So as our time increases, we start off by going fast, and then we start to slow down, and then finally we finish. There's no more products being formed because our limiting reagent was used up. Now part C. The experiment is repeated using the same mass of manganese oxide. Powdered manganese oxide is used instead. So what are we doing? We are increasing our surface area. Anytime we increase the surface area, the plateau isn't affected, but the slope is. So it's gonna look something like this. Now part D. In terms of particles, explain what happens to the rate of this reaction when the temperature is increased. When the temperature is increased, so increase in temperature, our kinetic energy of particles will increase, and then consequently there will be an increase in the collisions that are effective, and then as a result the reaction rate will increase. Very simply, in 4 steps we explained, and in terms of particles, what happens to the rate of this reaction. Now the equation for the decomposition of hydrogen peroxide is shown, and I don't think this one is coming, but there is no harm in doing it, so let's do it. Calculate the number of moles of oxygen. So at room temperature means RTP. RTP, if you remember from last year, is 24 decimeter cubed. And we have the volume in centimeter cubed. Definitely we need to change our volume into decimeter cubed, so it's gonna be, we're gonna change volume. So 48 divided by 1,000, we're gonna get 0.048, and we're dividing it by 24, which is our RTP. So if you do 0.048 divided by 24, you are gonna get 2 times 10 to the negative 3. So it is 2 times 10 to the negative 3 more. Now, deduce the number of moles of hydrogen peroxide that decomposed. So very simply, if the number of moles of our oxygen is 0.0, no, not 0.0, it's 2 times 10 to the negative 3. Oh my goodness, sorry for that. If the number of moles of our oxygen is 2 times 10 to the negative 3, so 1 mole gave us 2 times 10 to the negative 3. How much will 2 moles give us? It will be 4 times 10 to the negative 3. So here 4 times 10 to the negative 3. Now they're asking us to calculate the concentration of hydrogen peroxide in mole per decimeter cubed. So we have the total moles of hydrogen peroxide, which is 4 times 10 to the negative 3. We're going to divide it by the volume they gave us, which is 25 centimeter cubed. If you want to change it to decimeter cubed, we divide by 1,000, and we're gonna get 0.025. So then we are gonna get 0.16 mole per decimeter cubed. Oxygen can also be produced by the decomposition of potassium chlorate. The only products of this decomposition are potassium chloride and oxygen. So if we're gonna write it, it's gonna be KClO3 produces potassium chloride, which is KCl, and oxygen. Oxygen is O2. Is this balanced? No, it is not balanced. So to balance it, I'll let you guys balance. It will be like this. So our answer is 2 KClO3 gives us 2 KCl plus 3 O2. So that is it for the past paper of June 2020. Past paper 42, questions 4 and 3. Now we're gonna go to June 2019. So we have number 2 from the, let me check, from the May-June papers 2019. It's paper 62 and question 2. So we need to find the time in seconds. First of all, very simply, we can check the time. Here it is approximately, I would say 20. Why? Because here this is the midpoint, which is 22.7, so this is 20 seconds. Then for the second timing, it is around 34 seconds. For this timing, it is I would say 1 minute and 8 seconds or 9 seconds. Let's say 9 seconds. So 69 seconds. I'm not sure, maybe 68, 69 seconds. Then this one, it will be 1 minute and 37 seconds. So all in all, it will be 60 seconds plus 37 seconds, which is 97 seconds. So that is it for the first question. Now for the second question, we are gonna plot appropriately. I can't say it. Okay, so for one, like for each one, we have 0.8, how much was the second? 1, how much was the second? 1.5, how much was the second? And 2, how much was the second? So you guys are gonna plot it appropriately. I'm just gonna do it faster. So I know it's not accurate, but it's supposed to look something like this, and it will form a downward curving, not a downward, a downward sloping graph. So this is for part B. For part C, we're supposed to choose from our graph if it was 2.5. So if we were to follow our graph, we would do extrapolation. So let me redo the graph again. So this was our graph, and then we drew the line. Oh my goodness, I'm such a horrible drawer. So it's like this, and then by extrapolation, we would do it over here, and we would get a value that I don't know, but I'm assuming would be way less than 20. So it's x, let's say x is less than 20. Now here I'm just doing it briefly. You guys can do it like more accurately in the exam. So that was for C. For part D, what was the length of magnesium used in experiments 1 till 4? So let's go back up. In experiments 1 to 4, we used 5 centimeters. So in all of them, it was 5 centimeters. So the length is 5 centimeters. Now they're asking, why was the same length used? Why? Because it is a control variable, or to make it a fair experiment. Alright, now so just the effect on the results of experiment 1 to 4, we're using 2.5 centimeter length instead of 5 centimeter length. Now, because it is a shorter length, the results or the time, for example, will be faster. and it would be less accurate because it is a smaller amount of magnesium used. Now for E, suggest a different method which a student could use to investigate the rate of reaction, and state the apparatus the students would need to use. He could use, for example, a gas syringe, the syringe to take up the gas, okay? And what would he need to measure? He would need to measure the volume of gas, okay? And the time taken for the volume of gas to increase. For part F, okay, use the observation from experiment 5 to answer these questions. What type of chemical reaction occurs when magnesium ribbon reacts to dilute hydrochloric acid? So we go back to 5. Oh no, here, this was experiment number 5, part E. When the magnesium ribbon reacts with dilute hydrochloric acid, alright, heat will be released, so it is an exothermic reaction. Identify the gas produced. This is to be memorized. It is hydrogen. So that is it for the June 2019 paper 62 question 2. Now the next paper. Okay, so this is really simple. This is March 2021 paper 42 question 3. So nitrogen reacts with hydrogen to form ammonia in an industrial process. This industrial process is called the Haber process. State the meaning of this symbol. This is equilibrium. Alright. State the conditions used in this industrial process. The temperature is 450 degrees Celsius and the pressure is 2 atmospheres. The catalyst used in this industrial process is finely refined or cut iron. Alright, if the pressure is increased, the yield of ammonia increases. Explain in terms of equilibrium. Our imposed change is the pressure increases. We have here 4 gases and 2 gases. So it will favor, I'm sorry for the background noise by the way, it will favor the side with less gases. Okay, so NH3 has less gases, so the concentration of NH3 increases, so consequently the yield increases. If the temperatures increase, the rate of a reaction increases. Explain in terms of particles. Basically, if you increase the temperature, we did this before, the kinetic energy will increase. Then if the kinetic energy increases, the effective collisions will increase, and then finally the rate of reaction will increase. Now, ammonia reacts with sulfuric acid to make a compound which is used as a fertilizer. Write the chemical equation for this. So ammonia is NH3, reacts with a sulfuric acid which is it is H2SO4 to produce let's put the equilibrium, to produce fertilizer. What's this fertilizer? It is NH4 2SO4. So that is for the March 2021 paper 42 question 3. Now the next one. Okay, so now we have November 2022 paper 42 question 3. So we need to name a metal ore which contains sulfur. This one I had to search it up. It is zinc blende. I've never heard of this before, but apparently it's zinc blende. Now describe the process which converts metal ores to sulfur dioxide. Definitely if the metal ores react with the sulfur dioxide, how do the metal ores produce sulfur dioxide? They will have to react with O2, so it could be, for example, heat in air. Now name the industrial process used to manufacture the sulfuric acid. It's called the contact process. The reaction that produces sulfur trioxide is an equilibrium reaction. The forward reaction is exothermic exothermic. So that means we just need to fill in here the conditions. So the temperature is 450 degrees Celsius and the pressure is 2 atmospheres. Now the catalyst used in sulfur is called vanadium 5 oxide. This is V, sorry. 5 oxide. Okay, now describe two features of equilibrium. We know that in equilibrium, the forward reactions are equal to the backward reactions, and the concentration of reactants and concentration of products are constant. That's pretty much it, I think. I'm trying to think of any more. I don't think there is any more. Now, for IV, state the effect, if any, on the position of equilibrium when the following changes are made if the temperature is increased. So, our reaction is the metal plus O2 gives us SO2 because it's exothermic plus heat. Okay? So, if we are gonna increase the temperature, this is our imposed change. Temperature of exo is increased. According to Le Chatelier's principle, okay, there will have to be a partial counteraction. How does this happen? This happens by decreasing the heat or the temperature of our exothermic, and then as a result, to decrease the heat, then our products will have to give heat to our reactants. So it will be a backward shift, okay? Or it's a left shift, and the concentration of our products will decrease, whereas the concentration of our reactants will increase. Now, however, if we increase our pressure, so definitely we have the metal, which is a solid, plus O2, which is our gas, gives us SO2, which is our what? It is gas. So here, or actually no, sulfur gas plus oxygen gas gives us SO2 gas. So here we have two gases, and here we have one gases. We have more gases on the left hand side. So if we're gonna increase the pressure, it's gonna move from the two gases to the one gases, so it's gonna move to the side with the less gases. So it is a forward or right shift, and then the concentration of our reactants decreases as the concentration of our products increases. Now, explain in terms of particles. What happens when the temperature is increased? I don't know how many times we did this, oh my goodness. So what happens if temperature is increased? Particles' kinetic energy will increase. Then effective collisions will increase, and then as a result, the reaction rate will increase. And now finally, we need to name the compound formed when sulfuric acid, which is H2SO4, reacts with ammonia and H3. It will produce an H4 2SO4, I believe. So to balance it, we're just gonna put a 2 here, and now khalas, it is balanced. So what do we call this? This is called ammonium because this is ammonium, and then the SO4 is sulfate. So we call this ammonium sulfate. So this is it for November 2022 paper 42 question 3. Now I will go to the final paper and the final question. So our final paper is June 2021 paper 42 question 5. This question is about compounds of nitrogen. So nitrogen reacts with lithium to form lithium nitride Li3, and write the chemical equation. We know it is Li plus N2 will give us Li3. And is it balanced? No, it's not. So we're gonna put a 2 over here and a 6 over here to balance it. So now it is balanced. Anyways, B. Okay. The nitrogen reacts with fluorine to form nitrogen trifluorine. The chemical equation can be represented below. Some bond energies. Remember, bond energies is reactants. Heat of reactants minus heat of products. So calculate the energy change for the reaction between nitrogen and fluorine using the following steps. First, the energy taken in to break the bonds. These are our heat of reactants. Whenever they tell us the energy taken in, it is the heat of our reactants. So it is 1 N triple bond N plus 3 F single bond F. So if we're going to do it, it's going to be 945 times 1 plus 160 times 3. It is going to give us 1425. Then the energy released, which is for our product, it's going to be 1, 2, 3. We have 3 NF bonds multiplied by 2. So in total, it is 6 NF bonds. So it is now 6 times the NF bonds. We will get then 1,800 kilojoules. Now the energy change is the heat of reactants minus heat of products. So 1425 minus 1,800, if we do it on our calculator, we are going to get negative 375. Now, negative delta H is less than 0. If delta H is less than 0, then it is an exothermic reaction. So use your answer in part I to deduce whether this is an endo or exo. It is exo. Why? Because our delta H is less than 0. Okay, it is releasing heat. So now, triple I and C, we do not have it. However, D and E, I will see, and then I'll try and explain. So, calculate the percentage by mass of nitrogen in ammonium nitrate. We need the percentage of mass of nitrogen. What is the molar mass of nitrogen? The molar mass of nitrogen is, actually it's N2, so it is 14 grams. This is the molar mass. And then, let us find the weight of NH4NO3. So the mass of nitrogen, any nitrogen, is 14 grams. So here we have 2 nitrogen, so it's going to be 2 times 14 grams, which gives us 28 grams. All right, so then we're going to do 28 grams over the total mass, which is going to be 80 grams. And so then if you do it, you will get, on my calculator, 1 second, 0.35, but we need it as a percentage, so we're going to multiply by 100 and we will get 35%. Now state the use of ammonium nitrate in agriculture. It is used as a fertilizer. All right, state the name of a compound that will displace ammonia from ammonium nitrate. So in ammonium nitrate, it is NH3, NO3. And then they need us to get NH3. They need us to displace the ammonia from the ammonium nitrate. So definitely the thing we're going to use, I think it was in one of the previous papers, one of the previous questions, and it was calcium hydroxide, so CaOH. Now, part E, we do not have it, so definitely we're not gonna do it. So thank you guys for watching. I hope you enjoyed, and do really well in your exam tomorrow.